Hello, welcome to the study of root of an ordinary difference equation of second order with constant coefficient. Here we are going to look at a case where the roots are real and equal. Now we are going to let y is equal to m power x to be the solution of the ordinary difference equation. And then we shall let our m1 and m2 be root of the equation. That is ordinary difference equation. Here, m1 will be equal to m2 because the roots are real and they are equal. And all of them are real. m1 and m2 are elements of real numbers. Now, our solution of the ODE will be a linear combination of the independent solution of the differential equation. In this case, we will have y as equal to c1 exponential m1x plus c2 exponential m2x. Here, m1 is equal to m2, which is equal to m, meaning that where you have m1, you can substitute it with the m, and where you have m2, you can substitute it with the m. So, because now you have c1, c2, we can factor this is c2, we can factor exponential mx to be left with the c1, c2. Now, c1, c2, a constant plus a constant is equal to constant. So, we can substitute c1 plus c2 with a. So, here, a here is equivalent to c1 plus c2. So, a is equal to exponential, which is equal to a exponential mx. We call this Roman 1. Now, when you look at this solution, this cannot be a solution of a second order derivative because you have only a single auxiliary constant. So this is not the solution. So to get the exact solution or the correct solution, we are going to let our m be equal to m1 and our m2 be equal to m1 plus 8. Here, 8 is very small, or h tends to 0. So we are going to let limit as h tends to 0, or as h becomes smaller and smaller, this value of h will become 0, and we are going to have m1. So we substitute now here, y is equal to c1 exponential m1x plus c2 exponential bracket m1 plus h, everything x. Here c1 and the c2 are arbitrary constant. Then we can rewrite this one using the laws of indices. There is a law of indices which tells you like this: if you have a power n plus m, from the laws of indices, this is the same as a power n multiplied by a power m. So using this fact, we can split here. So we are going to have c y is equal to c1 exponential m1x plus c2 exponential m1x multiplied by exponential xh using this law of indices. Now, from Taylor's series, we can write exponential hx in this form here: 1 plus hx plus x squared divided by 2 factorial plus h cubic x cubic 3 factorial plus all the way to the last term. Then we substitute this value up here to obtain the following: y is equal to c1 exponential m1x plus c2 exponential m1x, which is the one here, this part here, then multiplying by exponential xh, which is this part from Taylor's series, which is 1 plus hx plus h squared x squared divided by 2 factorial plus h cubic x cubic divided by 3 factorial plus all the way to the last term. Then from there now, we can collect the likes with M1, the terms with M1, C1, exponential M1x plus C2 exponential M1x plus C2 x exponential M1x plus C2 exponential M1x h squared and x squared divided by 2 factorial all the way to the last term. Now here we can factor exponential mx to be left into bracket C1 plus C2, this one C1 C2 plus C2 hx exponential M1x plus C2 h x squared divided by 2 factorial exponential M1x. Now, as h tends to a small number, part here this part here will reduce to, will disappear, so that we are going to have y is equal to, we shall have y is equal to c m exponential m1x plus c prime x exponential m1x. Here c is equal to c1 plus c2, and c prime, this one, is equivalent to c2 8. Because when you multiply a constant with their constant, you are going to get a constant, whereby we can factor now exponential m1 to get this result here. So that is how we write a general solution of a second order differential equation with equal root which are real. So this is the general solution with equal root which are real. Now for more examples, tune in to my channel as I continue doing more examples for us. Thanks so much. See you in the next presentation as we continue learning together. Remember to subscribe if you are not yet subscribed to this channel. Also remember to share with the other mathematicians so that we may continue learning together. Thanks for your support. Bye bye.